Welcome to the greenhouse at CERF. CERF is the clean water educational research facility located at the wastewater treatment plant in the village of Manoa. At CERF, students conduct real-world research projects ranging from aquaponics to constructed wetlands. The heated greenhouse is where most of the student research is carried out year-round. The greenhouse is heated from this leaf pile, which produces heat from the process of decomposition. Leaf pile temperatures range from 110 to 140 degrees Fahrenheit year-round. Water is piped through the leaf pile, then to the soil in the greenhouse through a closed system. Heat is then transferred from the soil to the air, heating the greenhouse. Let's hear from the students about their research projects.
We're the aquaponics group, and our objective is to see if blue tilapia can survive and thrive in an aquaponics system in a colder climate.
This is our main tank where we take our temperature and dissolved oxygen. And this right here is where the water goes through to filter it and to then go into the pond where we grow our plants.
So in the pond we have a few things growing. We have arugula, we have lettuce, and then we have, I believe, cabbage or something like that. And so we're kind of measuring the plants every time we come in, making sure if they're growing, and if they're not growing, we report that kind of stuff.
So right now we are measuring various samples of our fish from our pond and determining how much growth we've had over the past few weeks.
$35.17.
Sounds good.
So we're trying to grow algae in a greenhouse environment by seeding algae in these plastic tubes called photobioreactors. And we're going to heat the water using a small aquarium fish tank heater. And then we're using this aerator to keep air circulating through the tubes.
So the whole purpose of our project is to convert algae into a reusable biofuel. Because of growing oil prices and the rapid depletion of oil, it's very hard and it's not very sustainable. So we're looking for other alternative resources such as algae which can be used. Now, once the algae does start to grow, we will collect it by taking small samples and then putting it in an oven at a 103-degree temperature and then taking the lipid count to see the amount of oil within the sample.
Alright, so I'm studying water purification and how it relates to the aquaponics system. So I take samples from 4 different spots on the aquaponics system. I take one from the main pond, the fish tank, the settling basin, and I also take some reactor effluent from the bioreactor. And then I go back into the lab and I test the ammonia and nitrate levels. The goal of my research here is to see whether the aquaponics system would be a suitable source of water purification for third world or developing countries, or even maybe lunar colonies eventually.
Hi, we're the Greenhouse Group, and our objective is to find out if plants that need pollination can thrive using non-traditional forms of pollination. In order to do this, we have to follow several steps. The first step is to build a greenhouse, which is what we're standing in right now. We use PVC pipes to create the frame, and we use plastic to create the walls. We then created pots so that we could plant plants, specifically cucumber plants. Our second step is to conduct the experiment. We started by recording data, so temperature data of the leaf pile, which we will discuss in 30 seconds, and of the soil and the air temperature inside of here, the air temperature inside of the bigger greenhouse, and the air temperature outside of this greenhouse. So the leaf pile that I mentioned, there's a pump inside of the greenhouse and the leaf pile that pumps water. And this water is heated by the process of the leaves decaying inside of the leaf pile, and this water is then pumped from the leaf pile into coils that are underneath here, and then back out and into a bucket, which we record the temperature of, and then back through the leaf pile. The heated water is what heats the greenhouse.
So I'm Abigail Harrington, and my project is with the anaerobic biodigester. And so within the digester, there's wastewater, and the microbes use the wastewater to produce biogas. And biogas contains carbon dioxide and methane. And we can collect that gas from this valve here by turning this. and we'll have the biogas come out. And so in our biogas, we would want a higher percentage of methane because methane can be used as an alternative fuel source because when it is burned, it turns into water vapor, so it's not releasing the greenhouse gas if we use it as a fuel source. And so inside of the digesters, going back to the microbes, my job is to make sure that it's at an ideal environment, so a thermophilic temperature and a good pH for the microbes to produce more methane than carbon dioxide. And so then I would test the pH and temperature. pH machine is in the lab, and then also take the gas to find the percentage of methane per time. So, really cool. We got our methane.
So we put the methane in the graduated cylinder. We put that into sodium hydroxide, and so it'll sit there for about 24 hours so that the carbon dioxide can be neutralized out. So then we'll have a milliliter reading of the methane, and then we can calculate that to a percent to see how much methane the digester is producing.
What I'm doing here is I'm measuring out 25 milliliter samples of each of these samples I took from the aquaponics system. I take them from 4 places. And so then what I do is I take this nitrate reagent and I put it in there, shake it up, let it sit, and then I put it into this machine. It tells me how much nitrates are in there. And then I will also take an ammonia reading. I will use these funky chemicals. This is mercury something, alcohol dispersing agent, and then this is mineral stabilizer. And then shake that all up, put it back in there, and that'll tell me how much ammonia is there.
These are just a sample of the amazing student research projects conducted at CERF, where student research skills are cultivated in a collaborative setting along with community support. This unique instructional design, where the teacher is the facilitator instead of the director of learning, allows students to be empowered to pursue their research interests. The skills students gain from their research experience will benefit them not only in college, but in their future careers.